This is section 5.5, and we're going to learn how to use the substitution method. So sometimes when we're going to be doing indefinite integrals where we don't have limits of integration, our normal rules don't seem to work, and we need to rewrite the problem so that it does work. And so we use what's called substitution, and we use it in certain cases. I'm going to give you some examples where we will use them and see if that makes sense, hopefully. So if you have an expression raised to a power, so find the integral of x cubed plus x raised to the fifth times 3x squared plus 1 dx. So it's not sensible to try to actually multiply all that out since that's raised to the fifth. So if we let that thing raised to a power be u, this is called the U-Substitution method often. So if we have u is x cubed plus x, then we take the derivative of this. So du would be 3x squared plus 1 dx. And what we notice is we've taken care of all the pieces here in the original integral. We've got the x cubed plus x. We've got the rest of this, the 3x squared plus 1 dx. So then we can rewrite the problem and say this is the integral of u, which is this piece, to the fifth power, du. Du is all of this. That's much easier to solve. So we now have u to the sixth over 6 plus c. Then you substitute back in what your u was. So now I have x cubed plus x parentheses to the sixth power over 6 plus c. Sometimes you'll see that written as 1/6 x cubed plus x to the sixth plus c. So when you have an expression raised to a power, that is commonly you would use U-substitution. If you have an expression inside a radical, so the integral of 2x plus 1 dx, if we let u be 2x plus 1, du is 2 dx. So we can see I have this taken care of in the blue, and I have my dx taken care of, but I do not have the 2. So what I would do is divide that 2 to the other side. So now I have 1/2 du is equal to this. So now I've got everything covered. I've taken care of the 2 because I divided it over here, and then I have my dx and my u. So when I rewrite, the 1/2 is outside the integration symbol. So 1/2 the integral of u to the 1/2 du. We're going to keep that 1/2 here. We're going to integrate u to the 3/2 because we're adding 1 to this over 3/2 plus c. Remember, when we have this on the bottom, we're going to invert it and multiply. So now we have 1/2 times 2/3, and we'll substitute back in. Here's my u, which was this, 2x plus 1 to the 3/2 plus c. Go ahead and multiply these together. You have 1/3, this to the 3/2 plus c. So expressions inside of a radical are often used. Or when we have a trig argument. So we have the integral of secant squared 5t plus 1 times 5 dt. So you let the argument be your u. So u is 5t plus 1. Du is 5 dt. Well, that worked out perfectly. And so now I have the integral of secant squared u du. The integral of secant squared is tan. So I have tan u plus c. Substitute back in. So tan of 5t plus 1 plus c. Be sure in your answers that you do put your plus c. It's going to count it wrong if you don't. So be sure you do that. So those are 3 examples. Let's go look and see what our problem sets look like. All right, number 1. And they start out giving you what u should be. So this really makes it quite easy, or easier, I'll say. So you have this integral, and they tell you let u be 3x plus 9. So we're doing the work. U is 3x plus 9. Du is 3 dx. So you rewrite your problem because that took care of everything. The integral of u to the 7th du. That's u to the 8th over 8 plus c. And So substitute back in, we've got this. I think MathLab likes this form. It may let you do this one, but I've written both here. So, just try to see what works there. All right, number 2, sine 2x dx, let u be 2x, because that's the argument. So if u is 2x, du, take the derivative of that, it's 2 dx. We don't have a 2 on the outside of the argument, so we'll divide that 2 to the other side, and we have 1/2 du is dx. So when you rewrite your problem, you now have 1/2 on the outside, you have sine u du. The integral of sine is negative cosine, so we have negative 1/2 cosine u plus c. Substitute your u back in and you have negative 1/2 cosine 2x plus c. And that should do that one. Let's look at number 3. All right, integral of 27 secant 3x tan 3x, u is 3x. All right, if u is 3x, du is 3 dx. We don't have a 3 out here. We did have a 27, but what I would have done at the beginning is pull that 27 through. So I think I showed you that here. So I don't have that. So I have 27 on the outside and I have 1/3 du is dx. So now I've got 27 times 1/3 times the integral of secant u tan u du. And the integral of secant u tan u is secant u. So you now have 27 times 1/3 is 9, secant u plus c. We'll substitute our u back in, and so we have 9 secant 3x plus c. All right, number 4. All right, we have the integral of 30s to the 5th ds over the square root of 3 minus s to the 6th. Remember, that's something in a radical, so they're saying let u be that amount there. So I would go ahead and pull the 30 through, and you have s to the 5th ds over the square root of 3 minus s to the 6th. That's how I would start the problem. Now, u is 3 minus s to the 6th. Du, the 3 goes away, and you have negative 6 s to the 5th ds. All right, well, we have an s to the 5th ds right here. So that's great, but we don't need this negative 6 in it. We don't have that covered, so we divide that to the other side. So we have a negative 1/6 du is equal to s to the 5th ds. So when you rewrite your problem, you've got negative 1/6 out here, you've got the 30 out here that we started when we started the problem, and we've got the integral of, and this is the thing that's left in the radical down here, so we're going to say that's u to the negative 1/2. That's the easy way to solve that, du. So this becomes negative 5. When we integrate, if you add 1 to that, you get u to the 1/2 over 1/2 plus c. This, if we flip it and multiply, now we have a negative 10 u to the 1/2 plus c. That's negative 10 times 3 minus s to the 6th to the 1/2 plus c. And go ahead and put it back in radical form for your answer. Probably that's what they want. Usually they want you to go back to the form that it was in. All right, number 5. Integral of the square root of negative 6 plus 7s ds. So inside the radical we have this. So u is negative 6 plus 7s. Du is 7 ds. We don't have a 7, so we'll divide that over here. So we have 1/7 du is ds. Rewrite your problem now. 1/7 integral of u to the 1/2 du. When you integrate, you have 1/7 u to the 3/2 over 3/2 plus c. That 3/2 inverts and multiplies up here with the 1/7. And so there's that. We're going to multiply that. We get 2 over 21. Substitute back in your u to the 3/2 plus c. All right. Number 6. We have something in the radical, 16 plus x squared, and it's the cube root. All right, so we have u is 16 plus x squared. The derivative of that is 2x dx. Well, we do have an x, we do have a dx. We don't have this 2, so we'll divide it over here, and we have 1/2 du is x dx. So we'll rewrite the problem, 1/2 on the outside integral, and since this whole thing is to the 1/3, if we change this radical, the cube root, so it's u to the 1/3 du. 1/2, when we integrate, we get u to the 4/3 because we're adding 1, which is 3/3. U to the 4/3 over 4/3 plus c. Invert that 4/3 and multiply it here, and substitute the u back in, and you have to the 4/3. So when we multiply this, we have 3/8, 16 plus x squared to the 4/3 plus c. Okay. This one is omitted, the 7 that was on that problem set. This is the new 7. Evaluate this integral, r squared times this amount to the 3rd power. So we're going to let r be what's raised to a power, u. So u is r cubed over 12 minus 8. Or you could write it this way. That'll be a little easier when you take the derivative. So du is 3 times that. So 3/12 r squared. The minus 8 is gone, and we have dr. I just rewrote it one more time to make that 1/4. So du is 1/4 r squared dr. We have r squared, we have dr, we do not have a 1/4, so we'll divide that this way, and when you divide the 1/4, that becomes 4. 4 du is r squared r squared dr. I don't know why I have that du. Okay, so when we rewrite our problem, we have 4 integral of u cubed du, and we'll integrate here, u to the 4th over 4 plus c. Those 4's cancel out, and when we do our final answer, we substitute our u back in. So we have this to the 4th plus c. Okay. Number 8 in your homework is a different problem than this problem set. So just mark this one out, and the problem is, and it's a good problem, you have to do a couple of different things, so this will prepare you for the number 8 that you have in your homework. It's the integral of p times p plus 8 to the 5th dp. All right, so this is something to a power. That makes sense. We'll do u equals p plus 8. du is dp. So we've taken care, if we do this again, we've got that, and then let's get a different one. Okay. And then the dp I've got. But what I don't have is this p. And that's not something I can't divide. I can't do anything there. But I'm going to solve for p in terms of u. Because right here we said u was p plus 8. So if u is p plus 8, p is u minus 8. If I subtract that 8 to the other side. So I've got that. So in my rewrite, I'm going to use this for the p. Okay? All right, maybe I should do another color there. Okay, so I've got that now so that we can see every piece is taken care of. So we'll rewrite with the substitution. This p, u minus 8, u to the 5th, du. All right, so now what we have to do is go ahead and distribute this u to the 5th to these two pieces. So that becomes u to the 6th minus 8u to the 5th du. Now we can finally integrate. U to the 7th over 7 minus 8u to the 6th over 6 plus c. And then it's a matter of plugging your u back in and simplifying this 8 over 6 to 4 over 3. So you have p plus 8 to the 7th over 7 minus 4 times that to the 6th over 3 plus c. All right, this one that was in the original is omitted. And we'll come down here to number 9. What is your number 9? Here's your definite integral, indefinite integral. This is something to the power. So we're going to say u is 9 minus x to the 5th. Du is negative 5x to the 4th dx. So we have taken care of the x to the 4th dx. We've taken care of this. We don't need this negative 5. We're going to divide that over to the du side. So when we rewrite the problem, we've now got negative 1/5 integral of u to the negative 2, because this was on the bottom, du. So when you integrate this, you get u to the negative 1 over negative 1 plus c. That negative 1 makes this negative 1/5 positive. So we have 1/5. We'll substitute our u in. Here's our u. And it's to the negative 1 power plus c. So now, since it's negative 1, it's on the bottom. So we've got this 1 on top. There's that. We've got a 5 on the bottom, and we've got 9 minus x to the 5th on the bottom, and plus c. So that's your final answer. All right, number 10. Number 10, a little bit different. All right, so in this number 10, we have the integral of 2 over 2x minus 4 ln 2x minus 4 dx. So I've color-coded over here, because if you let u be ln of 2x minus 4, the derivative of that is 1 over 2x minus 4 times the derivative of 2x, which is the 2. So du is 2 over 2x minus 4 dx. So 2 over that, and you have your dx. So you have everything. So you rewrite the problem, integral of 1 over u du, 1 over u du. The integral of 1 over u is ln u plus c. So we have ln, and our u was also a ln, so you're going to have 2 of those in absolute value bars. So ln, absolute value, ln 2x minus 4, that was our u, close, plus c. It's not too bad, it works out nicely. All right, number 11, which I think is our last question. Solve the initial value problem. So you're given that ds dt is 20t times 5t squared minus 3 all to the third. Well, the s is the integral of this right here. So we have the integral of 20t, 5t squared minus 3 cubed dt. Pull the 20 out so that you've got this. Then you let u be 5t squared minus 3, and then du would be 10t dt. You do have the t dt. You don't have the 10, so we'll take 1/10 du equals that. Now we'll rewrite the problem. The 1/10 is on the outside, the 20 is on the outside, u cubed du. When we integrate, we have u to the 4th over 4. This became 2, and then plus c. So this is 1/2. So s is 1/2. Put your u back in, 5t squared minus 3 to the 4th plus c. Now, it tells you that they want to know the initial value problem when s of 1 is 2. So we're going to plug in 2 for s, and we're going to plug in 1 for t. So we have 2 equals 1/2. That stays at 5. 5 minus 3 squared plus c. 1/2 of 5 minus 3, 2 to the 4th is 16 plus c. And so now all of that comes down to 8 plus c. So 2 is 8 plus c. Subtract 8 and you get negative 6 is your c value. So your function is now s equals 1/2 5t squared minus 3 to the 4th, but now we have a value for c based on this s of 1 is 2 of -6. So that is our final answer. So hopefully you can get that one. Substitution is, it's just keep doing the same things, and I think it will be okay for you.